Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic conductance of electrolytic solutions. Now see the electrical resistance. First let us see the resistance. The electrical resistance of a conductor is denoted by the letter capital R and it is measured in ohms. The electrical resistance of a conductor is represented by R and is measured in ohms. The electrical resistance of any object is directly proportional to its length and inversely proportional to its area of cross section, which is denoted by A. So R will be equal to rho into L by A. This constant of proportionality rho, this one, is called as resistivity. The constant of proportionality rho is called the resistivity. The SI unit is ohm meter. SI unit is ohm meter. Now if we take the inverse of resistance, we call it as conductance. Inverse of resistance is conductance. G is equal to 1 by R. And inverse of resistivity is called as conductivity. Inverse of resistivity is conductivity. Now, whenever we know that the metals are good conductors of electricity and electrical conductance through the metals is called as metallic or electronic conductance. Metallic or electronic conductance, and this is because of the movement of electrons. The conductance in metals is due to movement of electrons. Now in case of metals, the conductance will depend upon the nature of the metal, the structure of the metal, and the number of valence electrons per atom of the metal. In the metal, in every atom, how many valence electrons are there, that will be a deciding factor. It also depends on temperature, because it decreases with the increase of temperature. As the temperature increases, it will decrease. In case of electrolytes, the conductance of electricity by the ions which are present in the solution is called electrolytic or ionic conductance. Electrolytic or ionic conductance. Now, in case of electrolytic solutions, the conductivity will depend upon first nature of the electrolyte. Stronger the electrolyte, they almost completely get ionized in solution. If ionization is almost complete, we get to call them as strong electrolytes. So nature will decide the conductance. Second is size and solvation of ions. When the dissociation of the electrolyte takes place, the size and solvation of ions is important. Now, whenever there is solvation of ions in the solution, the solvation of ions will decrease the electrical conductivity. It will decrease the electrical conductivity. Why? It is so because when there is solvation, they become heavier. When they become heavier, their mobility will decrease. When the mobility decreases, it will decrease the conductivity of the solution. So, solvation of ions in a solution decreases its electrical conductivity. Next is nature and viscosity of the solvent. Nature of the solvent is very important because in case of solvent, its main function is to weaken the electrostatic forces of attraction between the ions. So when it weakens the electrostatic forces of attraction between the ions will get separated. Now in case of ions, the force of attraction holding the ions together in any medium is given by the formula F equal to 1 by K Q1 Q2 by R square. F equal to 1 by K Q1 Q2 by R square, where K is the dielectric constant of the medium. Now any solvent which has a high value of dielectric constant has the capacity of separating ions. Water is considered to be a base solvent because it has the highest dielectric constant. Any solvent which has high value of dielectric constant has the capacity of separating ions. Next important factor is concentration of electrolyte. The extent of ionization of an electrolyte is inversely proportional to concentration of the solution. That is, how much ionization of electrolyte is going to take place is inversely proportional to concentration of its solution. So degree of ionization increases with the increase in dilution of the solution. Degree of ionization increases with the increase in the dilution of the solution. That is, increase of dilution of solution, that is decreasing the concentration of the solution. Temperature also plays an important role. It increases with increase of temperature. The degree of ionization increases with increase of temperature. So this is due to the fact that at higher temperature molecular speed is increased, which overcomes the forces of attraction between the ions. So the degree of ionization increases with the increase of temperature. Okay. So this is all about this topic. I hope students you all could understand whatever I discussed today. Thanks for watching my video. Please subscribe to the channel. Thank you.